You are listening to The Vocal Technologist. Spoken Tech for your ears.
Welcome. If you're out there building data products, the kind that have to deal with serious scale, serious cost pressures, and just this constant kind of chaotic arrival of new AI tools, well then, the speed of change right now is it's dizzying. Feels like we're always fighting to stay relevant while needing everything to be absolutely bulletproof. So today, we're aiming to give you something like a blueprint. We've looked at the latest shifts in architecture, the new demands around quality control, and the real impact of generative AI, the goal. To show you what a production-ready data stack really looks like heading into 2025, think of it as getting your systems and maybe your career too ready for what's next.
That's right. I mean, the fundamental thing happening in data engineering is this big pivot away from those old monolithic systems. We're moving fast toward components that are modular, super efficient, and increasingly AI-enabled. Understand this is pretty critical for figuring out where to put your engineering effort this year.
Okay, let's unpack this. Maybe start with the money. Infrastructure costs is always, always top of mind. Companies are really grappling with avoiding vendor lock-in, optimizing spend, but without killing throughput. So what's the secret sauce architecturally? How do you get faster and cheaper right now?
It seems like it's two things, really.
Right.
Smarter architecture and specialized hardware. We're definitely seeing a strong trend towards modular SaaS components that plug into high-performance computing, like AWS Graviton 3. That's delivering something like a 40% improvement in price performance. That's pretty compelling.
40%, wow. Yeah, that definitely moves the needle on the budget straight away.
Absolutely. And you see companies building these sort of data stack templates. They're trying to embed governance and cut costs right from the start. Aerospike, for example, they reported a 27% annual cost reduction just by streamlining their architecture templates. But the real strategic play against getting locked in, that comes down to infrastructure tools, things like unified query routing, and this is crucial, committing to open table formats.
Okay, hang on. Why are those two specifically? Routing and open formats, how do they shield you from vendor dependency?
Well, because they let different engines work together seamlessly. If you can query your data, whether it's sitting in a data lake, a cloud warehouse, or some specialized engine, then you're not stuck with one provider for everything. Storage, processing, you get flexibility instantly.
Right, okay. And that flexibility must be vital when you hit scaling challenges. This is where it gets really interesting for me. How do you deal with what the reading called a combinatorial data explosion, where every new filter just multiplies the complexity and grinds everything to a halt?
Yeah, that takes some genuine engineering creativity. The big example we saw was Netflix. They had to completely re-architect their Muse platform because it was hitting trillion row scale. The original setup it couldn't cope. Demands for complex audience grouping, advanced filtering, query latency went through the roof.
Yeah. Trillion rows times complex combinations. Your performance is just dead. So what was the clever fix, the technical solution?
They really leaned into approximation techniques. The core thing was using hyperlog sketches, which, for anyone listening, is a really smart, if slightly fuzzy way to count unique items in huge data sets incredibly fast. You trade perfect accuracy for massive speed, and they paired that with pre-computed aggregates stored in memory. By optimizing how they stored and queried data within their existing Druid setup, they got huge wins. They actually cut their P99 query latency. So the slowest experience for users by half, 50%.
That's a massive improvement. And I like that they optimize the existing architecture rather than trying some huge multi-year replatforming nightmare. It really shows the power of, surgical engineering.
Okay, so that helps on the batch side. But what about streaming? That relentless real-time pressure? I'm seeing Rust and columnar processing pop up everywhere as keys to efficiency. Oh, absolutely central. That's the whole idea behind the RED Stack Rust Arrow Data Fusion, because they use that efficient columnar structure and vectorized execution, basically processing data in big chunks, not row by agonizing row. Teams are seeing real throughput gains, often 2x, sometimes even 5x faster. It just handles the bits and bytes more effectively. And we should definitely talk about streaming joins. That's always been a massive pain point, right? State bloat. Flink 2.1 brought in things like delta join and multi-join. They're specifically designed to tackle that state nightmare. What they do is offload the historical data, the stuff that bloats the state, to external stores like Apache Flux. the result. Recovery times drop from, potentially minutes down to just seconds.
Minutes to seconds. That sounds almost revolutionary for keeping things stable. But there has to be a catch, right? If you're offloading history.
Eventual consistency, yep, you nailed it. That's the critical trade-off. For systems where you need absolute, right now, consistency, think financial ledgers, maybe real-time inventory. This specific Flink approach might not work. But for many use cases, like, say, enriching event streams with data that changes slowly, that eventual consistency is often perfectly fine. And the gains in reduced complexity and faster recovery, totally worth it. It's really about matching the tool to the specific job.
Okay, fantastic clarity there. Let's shift gears a bit. From the purely technical scale to, let's call it, organizational integrity. Scaling the pipes is one thing, but if the data itself is wrong, the whole product just fails, often spectacularly. How are the best teams building trust and quality right into their day-to-day work?
Well, the biggest threat often isn't just like random system bugs. It's more about unclear ownership within the organization, messy source data, constant changes. So the solution gaining ground is continuous testing. But not just as a final check, right? It's integrated directly into workflow tools like Airflow. Data engineers are actually embedding quality checks, often using reusable task groups, right alongside the data transformation and loading steps. So you stop relying on finding problems after the fact. Verification becomes part of just getting the job done. Definition of done.
That raises a really important point, though, because this integrity thing, it's not purely technical, is it? One piece we looked at flat out said data is political. We kind of have to talk about the organizational friction, because even if all your pipeline tests are green, if the underlying data model reflects some internal bias or disagreement, the product built on it is still flawed.
Oh, absolutely. Data modeling is inherently political, always. The final structure, the definitions, they're rarely just about pure technical optimization. They get shaped by negotiations between departments, by different internal definitions clashing, sometimes even turf wars over who owns a piece of data.
So succeeding here isn't just about being great at Python or SQL anymore. It sounds like it demands a whole different skill set. What are the roles a modern data pro needs to play?
Yeah, you got to wear three hats, basically. First, obviously, the technical expert. That's table stakes. Second, you need to be a bit of a persuasive salesperson. You have to sell the value of your model, defend its choices to people who might be skeptical. And third, you have to be an empathetic servant almost, mediating conflicts, translating what the model means for different, sometimes competing parts of the business.
Can you give a concrete example? Like, what kind of conflict are we talking about?
Sure. Think about defining an active customer. Simple, right? Well, sales might say it's anyone they talked to this quarter. Marketing says it's anyone who clicked an email in 60 days. Finance says, nope, only people who actually paid in the last 90 days. See? Three totally different definitions leading to different numbers, different strategies maybe. The data professional's job is often to get those groups in a room, mediate that, agree on the definition for this purpose, and make sure everyone actually uses it. And that only works if you have, a high-trust, psychologically safe environment. Otherwise, those models just break down under the internal politics.
That perspective on governance and politics is really crucial. Okay, let's pivot one more time to the AI frontier. We hear about LLMs constantly. But how is data engineering actually working with them, not just feeding them data, to create genuinely new kinds of value?
We're seeing some really interesting techniques that kind of flip the script. Take something called LLM deflate. It's basically a method to systematically pull structured data sets out of large language models.
How?
By kind of reversing their internal data compression. Since an LLM essentially compresses vast amounts of knowledge into its parameters, you can try to reverse that to extract structured information.
Okay, intriguing. What's the practical use case for that LLM deflate?
The big one right now is generating high-quality synthetic data systematically. This could be huge for training specialized AI models safely and efficiently, especially when you don't have massive, perfectly labeled real-world data sets where you can't use them due to privacy.
Speaking of privacy, what about anonymization? That used to feel mostly like a compliance checkbox, but it seems like it's getting a new strategic role.
It absolutely is. Anonymization is now being framed as a key enabler for doing AI and analytics safely. You see companies like Microsoft with their private evolution work, or Google with Vault Gemma. They're demonstrating this. Stronger anonymization guarantees, perhaps using differential privacy, can actually improve how well models generalize because they limit the risk of the model just memorizing sensitive training data. Right. So it unlocks data for analysis while managing the risk. It's becoming a feature, not just a burden.
Okay, so given all this, The pace of tech change, the political dynamics, the new AI stuff, what does it all mean for the actual people building these systems, the data professionals on the ground? What's the career advice?
The consensus seems really clear. Prioritize hands-on experience with real production-grade systems. That's what builds credibility and drives rapid career growth now. Just deploying a proof of concept, a POC, that's not really enough anymore. Taking ownership, seeing a project through its entire life cycle, the messy parts included. That's where the value and, frankly, the promotions are. And related to careers, we have to touch on this kind of paradox with AI assistants. We sort of expected AI tools to really boost junior folks, right? But so far, the evidence suggests the opposite. AI is actually helping senior developers more.
Huh. Why is that happening?
Well, because AI today is really good at automating the repetitive stuff, the boilerplate code, maybe fast prototyping, things seniors already understand well and could maybe delegate anyway. But AI still struggles with the bigger picture.
Yeah.
It's architectural soundness, potential security holes, overall code quality, and maintainability. You still need experienced engineers to guide the AI to vet its output to make sure the result is actually robust, secure, and scalable for production. So the AI helps seniors go faster, but it hasn't yet replaced the need for that fundamental experience juniors are trying to build.
That might be one of the most important takeaways for anyone listening who manages a data team.
Wow.
Okay, we have covered a lot of ground today, from, clever tricks like Hyperlog for hitting trillion row scale to shifting towards these modular cost-saving stacks, all the way through embedding quality checks continuously and needing those crucial soft political skills to actually make data models work in an organization. This is foundational stuff for any vocal technologist out there.
And if you kind of zoom out, connect the dots, you can see a fundamental shift happening in how value is exchanged across the whole internet. And that definitely impacts every data product being built.
Exactly. Which leads to maybe a final thought to leave you with. Cloudflare, in their annual letter, pointed out something pretty seismic. These AI-powered answer engines, think super smart chatbots. They're starting to replace traditional search engines for finding information. And this is already causing drastic drops in traffic for websites that provide content, like media sites or research portals. It potentially threatens any business model based purely on getting clicks from search results, because the value seems to be shifting towards whoever creates the original high-quality data that the AI scrapes to generate the answer. So, the question for you, as someone building data products, is this. If direct answers start replacing website visits, if that whole consumption pattern flips, how does your organization make sure its unique, valuable data gets compensated? And how do you build products that offer sustainable value when the way people find and use information might be fundamentally changing? Definitely something powerful to think about as you design your next system. Thanks so much for joining us today.
My pleasure. Thank you.
Until next time.
Spoken Tech, for your ears.